And you can kind of wait and see if you want. You might want to have your notes out that had those practice problems, but really, there's two type of problems that we're going to see. One where it gives you two time values, so like 2 hours, 2 minutes, or minutes, hours, days, weeks. You're looking for 2 units that are telling you time. You also might be given a question where it gives you 2 sample amounts. Those you're going to be looking for like the grams, the milligrams, the kilograms. So the units that go with the numbers can kind of help clue you in. But you're either going to see 2 times or you're going to see 2 sample amounts. And depending on what you're given, that's the approach you'll take. All right, so we'll do a couple examples of each type, and then you'll have a few to do on your own to see kind of like, are you getting the hang of it, kind of thing. Let's start first with, let's look at number 1. Okay, I would like you to do it the way I'm going to do it, at least for today, like as you're kind of getting this practice in. Something that I didn't talk about necessarily was typically when we do math problems, we're going to underline the information that's given to us. So that way it stands out in the problem. So for number 1, it says an isotope of cesium-137 has a half-life of 30 years. Well, here's a piece of information. The half-life is 30 years, so I'm going to underline that. If 12 grams, well, that's a piece of information, decays over a period of 90 years, how many grams would remain? So I'm going to circle what I'm solving for. I'm solving for how many grams. And so every time we do like calculations like this is the way we're going to start it. Underline the things that are given to us, and then we are going to circle what we are trying to find. Okay? So typically, we are going to look for those 2 things. Are we given 2 times, or are we given 2 sample amounts? So looking at this, what do you see 2 of? I see 2 times. So when we have 2 times, we're going to take that total of 90 years, right? And I'm going to divide that by the 30 years. Because I want to know how many half-life cycles it went through. Okay? And so most of this math is actually very, very simple math, right? So since we saw the 2 times, we're going to divide those 2, and that will tell me how many half-lives this went through. Now, the question isn't asking how many half-lives, but we can't solve it unless we know how many half-lives. So that's always going to be our first step. So what is 90 divided by 30? Okay, so let's give actual answers and not be confusing to the people at home that are watching this. Like, let's not make it harder than it is. Give the real answer. Don't be silly. So we are given, we have 3 half-lives. Now, HL is not really a true unit or abbreviation or anything like that. It's just something I kind of make up. Half-life, HL, just so I know that I'm dealing with 3 half-lives. Okay? The next step, if you remember from our notes, is that we have to take the amount of the sample that we started with, and then how many times are we going to have to divide it in half? How many times are we going to have to divide it? I'm seeing some 3s, right? Because it went through 3 half-life cycles. So we have to cut it in half 3 times. So again, this is kind of part 2. So I'm going to switch colors just to keep it kind of visually different for you. So I have 12 grams that I'm going to divide in half once. And what do we get? And then I'm going to divide it in half again to get what?
3.
And divide it in half one more time to get my final answer of 1.5. And here's where I have to make sure I include my units, and it's the gram. I know that from up there. This is my final answer. Now, here's what I would suggest you do. I would suggest you either draw 1, 2, 3 arrows, and that better match your half-lives, or some people like to do like 1, 2, and they count them 3. Something kind of visual to let you know I have done the amount of half-lives that I should. Because if you just have your calculator and you're plugging in 12 divided by 2, that divided by 2, that divided by 2, that divided by 2, you can lose track pretty easily. Like, I would write it out, it just takes a second, it's not that hard to do. I will guarantee that many of you will make the mistake of dividing only maybe 2 times by 2, or maybe you'll do one extra division and divide 4 times by that 2. If you write it out, you have a less chance of making that mistake. Okay? So, we needed this answer so we would know how many times we had to divide. Good? So this is an example if you're given 2 times. So you might even want to put 2 times given. And that way you know if you have to solve for a problem that's when 2 times are given, you can look back at number 1 and see that. Okay? Let's go to let's go to number 6. All right, so following our little strategies, it says the half-life of polonium-218 is 3 minutes. How many half-lives would it go through in 15 minutes? Then determine how much of a 66-gram sample would remain after 15 minutes. So it actually has it worded for 2 parts. The first one didn't, right? We just knew we had to solve for the number of half-lives before we could solve the rest of the problem. So give me a piece of information that's given in this problem that we need to underline. Cool?
Half-life is 3 minutes.
Good. So half-life is 3 minutes. And it's kind of a lot to underline, but we want the 3 minutes to go with half-life. What else is given? Cade, give me something.
That it decays over a period of 58 hours.
Well, we're on number 6. What's another piece of information given?
15 minutes.
Okay, so we're going to use 15 minutes. And then what's another piece of information? There's one more given. So we have an original amount, right? So what do you see 2 of in this problem? See 2 times again. So we're going to have kind of the same setup as we did for number 1. First, we're going to solve for how many half-lives, and then how much would remain. So if it's asking for how much it would remain, obviously we're looking for a sample amount. So if we set up, just like we take our total time of 15 minutes and divide it by our half-life of 3, in that 15 minutes, it went through how many half-lives? 5. Okay, so 5 half-lives. And again, HL, I just kind of made it up. I don't know if anybody else uses it, but it makes sense to me instead of having to write the whole word out. So if I have 5 half-life cycles, that's telling me I'm going to have to divide by 2 5 times. So what is my starting amount? So that's the answer to part number 1, right? What's the starting sample amount? Good. So we're going to start with 66 grams. We just have to start cutting it in half. 66 divided by 2. What's 33 divided by 2?
16.5.
Okay. And then we have to divide that by 2.
8.25.
8.25. And let's see, don't get trapped. 1, 2, 3. So we still need to keep going. What's that divided by 2?
4.125.
Okay. So at some point, you can like round some of this. I mean, like, I don't care either way, I guess. It's up to you. One more division, right? 1. And what did we get?
2.05.
So like maybe like 2.1-ish. Will that work? Okay, so let's double check. I'm going to make sure I divided by 2 5 times. That was 1 division, another, 3rd, 4th, 5th. Every time I see divide by 2, I put my arrow. And I better have 5 of them to reach my 5 divisions I needed to take. So my answer, and just because I ran out of room, I'm going to kind of rewrite it. 2.1 grams should be our final answer. Again, usually don't care how you round, unless it's for a lab, and then I will tell you, hey, you need to go to tens, or you need to go to hundreds, but like on practice calculations, whatever works good for you. Okay? Let's look at the other type of problem. Okay, we're actually, let's go to number 7. Oh, I guess I can like that one up there. All right, so carbon-14 has, typo, half-life of 5,730 years. How many half-lives did the bone go through if it presently contains 0.3125 grams of carbon-14 and it originally contained 80 grams of carbon-14? Then determine how old is the bone. So give me a piece of information I need to underline. Emily? Good. What else is given? Originally contained. So original, you have to kind of decode that. That means what you started with, right? And then what else is given? Charles, what do you see? What other piece of information is given to us?
Contains 0.3125 grams.
Very nice. So it presently contains that much. All right, so we're solving for how many half-lives did it go through and how old. What do you see 2 of? What do you see 2 values of, Anthony? Do you see 2 times or do you see 2 sample amounts? Okay, so we're gonna take our 2 sample amounts, right? And we take, where'd it go? 80 grams is what we started with. And we're gonna divide that in half until we get to the 0.3125. So we just have to keep dividing and dividing and dividing, because 80 got cut in half a bunch of times until it got to the 0.3. So let's start dividing. 80 divided by 2 is what? 40 divided by 2 is what? 20 divided by 2? 10 divided by 2? 5 divided by 2?
2.5.
2.5 divided by 2? 2.5 divided by 2? Wait. 2 divided by 2?
1.2.
Okay. Now Cade, or Cole,
0.625.
okay. 0.625, and then that divided by 2?
0.3125.
Oh, thank goodness. 0.3125, and I stopped because that's what I was trying to get to. Holy smokes. Okay, so 1, 2, 3, 4, 5, 6, 7, 8. So my answer for part 1 is 8 half-life cycles. That's how many it went through. Second part, how old is the bone? Well, how long was each half-life? Charlie, how long was each half-life? What's that information that's given to us for carbon-14? You're not sure? Okay, so does anybody see, what's the half-life? Yeah, that was a piece of information that was given to us, okay? So you take the 5,730 years, and then how many of those cycles did it go through? 8, we just calculated that. So we have to take, for part 2, our 5,730 and times that by 8. 45,820? 840, and that's years, right? The units are important. And that is my final answer. And I'm kind of out of room. So you go from your original, divide by 2, by 2, by 2, by 2, until you get to your final amount. And then you count those divisions up, and that tells you how many half-lives. And then from there, you can multiply it by what the half-life actually is, so you know how much time has gone by. Yes? No? Good? Okay. Let's take a look, excuse me, at number 8. Okay. What is the half-life, well, so that's what I'm solving for, of a radioactive isotope if a 500 gram sample decays to 62.5 grams in 24.3 hours? So give me a couple things that I need to underline that are given to us. Give me one of those, Austin.
500 gram sample.
That's what I'm starting with. Michaela, give me something else. That's where we end up.
24.3 hours.
Good. And that's like our time period, right? Okay. So we're going to determine what the half-life for this actually is, right? So the first thing, what do you see 2 of? 2 samples, right? So I'm going to take my 500 and I'm going to try to get to 62.5. So I'm going to start cutting this in half. What do we get? It's 500 divided by 2. Divided by 2.
1.5.
Divided by 2.
62.5.
Ooh, that looks good, right? That's where we're trying to get to. So we stop there. Okay? So how many half-life cycles did it go through? Went through 3 of them. Okay? So we went through 3. That kind of gets us like our first piece of information. Now from here, we want to know what is each half-life. So we have the total amount of time now, right? What we don't have is what amount of time was each one of these cycles. So we have to have something that equals up to 24.3. So how are we going to figure that out?
Divide the amount of time by the half-lives.
Good. So we have a total time of 24.3 hours. And we know if we would split that in 3, each one of those would represent the half-life. So 24.3, divided by 3 gives me what?
8.1.
Shocker, right? 8.1 hours. And that makes sense, right? Because you have 8.1, 16.2, and then you get your 24.3. So just a little twist on that final. So we could calculate what the half-life actually is as long as we have the total. Or if we have the half-life and we know how many half-lives it was, then we can find the total hours. So you can go either way. What do you guys think? You have 2 examples for samples, number 7 and 8. You have 2 examples when 2 times are given, number 1 and 6. I would like you guys to work on, actually hold that thought. Do you guys want to do one of the graphing ones together, or do you feel, raise your hand if you want to do one of the graphing ones together. Okay, I agree with that. I like that. Let's do 12, 13, and 14. It goes with isotope Z. All right. So I'm going to orient myself with what I see. I see the age of the sample in years down here, and I see percent of the radioactive material remaining, and I see my curve line, my decay line. So what is the half-life of isotope Z? Well, if we're starting at 100%, what is half of 100?
50.
So I'm going to go to my 50, and I'm going to put a dot, right? And I know I'm going to go down here. Right? So what is the half-life of this sample? Yeah, it's just going to be 1 year, right? Because I go from my 50, which is half of the sample is decayed, and the amount of time that is, we just go from that line, drop down to my age line. So 1 year. Again, include the units. Okay, so 13, how many half-lives have passed if 25% remain? Well, if you take 50 and cut it in half,
That's 25.
it's 25. So if you go to 25, right, and that takes you to 2 years, how many cycles have you gone through to get there? 2. 2 half-lives have gone by. And now it says after 3 half-lives, so we're gonna be looking at this area, right? So we're gonna go from there up to the line, and then we're gonna go over to here. Approximately what percent is left at that point?
12.2.
About 12.5, or, you know, approximately 12 or 13% would remain. Okay? All right, so number 9, 10, and 11 for that first graph, and then number 2, 3, 4, and 5. So really what your job is to finish out this paper to make sure that you are good at being able to do these on your own. When you get done, bring it up to me so I can check, or if you get stuck, bring it over. I'm not gonna like harass you, but if you have questions or you get stuck, look at those examples first, and then if you're still stuck, then come and see me. Good? All right, I'm gonna turn the lights back up.